The 15th question says, does the point minus 2.5 comma 3.5 lie inside, outside or on the circle this? Okay, minus 2.5 comma 3.5, this particular point we are looking at, this particular point. And how do we observe this particular point? The location of this particular point. Let's say we know the center of the circle and we know the radius of the circle. And we want to find the position of any point, whether it lies outside, whether it lies inside or whether it lies on the circle. Now a point on the circle is very simple to find, right? If you have the center C and let's call this point P, point Q, point R, okay. If you observe, for a point on the circle, you can observe that the distance CQ is simply equal to the radius. Yes, for a point on the circle, the distance from the center will be equal to the radius. Yes. Okay, this is very simple, right? So what happens in case point is outside? So for a point which is outside the circle, how do we check? Okay, once again we try to join this and this, at this particular point we get the radius. So this distance of C from P should be greater than the radius of circle. Yes, for a point outside the circle, this is the condition. For a point inside the circle, CR, this distance CR, do you observe that CR is less than R? Yes, and those are the important results related to position of point with respect to a circle. Does a point this lie inside, outside or on the circle? For that, let's analyze that circle. That circle is x minus 0 whole square plus y minus 0 whole square is equal to r square. So center is 0 comma 0 and radius is equal to 5. This is what we have. Right, we have written the equation as x minus 0 square plus y minus 0 square and 5 square, and we have compared with the equation of the circle in standard form, found the center as 0 comma 0 and radius as 5. This is what I have, right? And point P is any point 2.5 comma 3.5 like this. We have to check whether P lies outside, on or inside the circle. So for that, we'll have to find the distance of center from this point P. Yes. So CP is equal to what? CP is equal to minus 2.5 minus 0 square plus 3.5 minus 0 square and its under root. Right. This is what you get. What else? This here is minus 2.5 and this will actually become, can I write it as, actually this is 2.5 square only and this is 3.5 square. Okay, can I find the squares? Yes, I can find the two squares easily. 2.5 square is 6.25 and this is 12.25. Pretty simple, yes. And this total will become 18.5 under root. This is what I'll have. Now CP as compared to this radius, can you identify? The value of radius is r, the value of radius is 5 and this root of 18.5, is it less than 5 or greater than 5? Just imagine 5 square is 25, okay. So this is the root of 25 and root of 18.5 will be less than 5, right? So this is somewhere around 4 point something, this is obviously less than 5. Oh, this tells me that CP is less than the radius, yes. If CP is less than the radius, then you can say that point P, that is minus 2.5 comma 3.5 lies inside the circle. Lies inside the circle. That's what you can note, right? This is this particular question, as you can see, and that's the complete solution of this question over here. And with this we come to the conclusion of this exercise number 11.1 from the chapter Conic sections. In this exercise we saw questions based on circles. In the next exercise we'll be seeing questions based on parabola. Till then, all the best.